Okay, 2.10, modeling with algebra. So in this section, I'm going to go through some examples on how we can take whatever word problem we have and model it using expressions or equations. This is algebraically. Okay, so here's our first example. So Sam is 4 years older than Chris. The sum of their ages is 36 years. How old are they? To turn this word problem into an algebraic problem and to solve it, I'm going to give you a little outline of how you would do this step by step. Okay, so step number 1, we are going to create let statements. You might remember what these are. I think I explained them a number of lessons ago. So let statement looks like this. I'm going to say let x. So this is the way we define our variable to represent something in the word problem. So I'm going to let this variable x represent Chris's age. Okay. And I need one more let statement. So we also have we have to create one for Sam. So we're going to say let. Now, if we know Sam is 4 years older than Chris, and I know Chris's age is represented by x, then Sam's age is going to be x plus 4. So let x plus 4 represent Sam's age. Okay, by doing this, we don't need to make a second letter for Sam. We just use Chris's letter x already for Sam's as well. Just make that expression x plus 4. Okay, so those are our let statements. Step number 2, create an equation. So our equation is going to be, based on what they're giving us in the problem, the sum of their ages is 36 years. So sum is a key word there. I'm going to be adding their ages. Okay, so I'm going to take Chris's age, x. I'm going to add it to Sam's age, x plus 4. And that's going to equal 36. Step 3, solve. Solve your equation. Okay, so let's solve this equation. Solve it for x. So I'm not multiplying any binomials here. Notice there's a plus sign, so I'm not going to be doing x times x and x times 4. No, it's not at all like that. When I remove the brackets, I only put the brackets in there just to isolate to show you that this is representing Sam's age. But when I remove the brackets, watch out for any negative signs. Here we're okay. So x plus x make 2x, and I have a plus 4, and that equals 36. Okay, solving for x, if I subtract 4 from both sides, I will have 2x equals 32. And if I divide both sides by 2, I will have x equals 16. Okay, now we have x. Step 4 is to answer the question. So what does the question ask? Well, the question asks, what are, or how old are Sam and Chris? Okay, so x is equal to 16. And we already said that x represents Chris's age. So in my concluding statement, I'm going to say, therefore, Chris is 16. And we also need to express Sam's age. So it will be x plus 4. So Sam is 20. 16 plus 4 is 20. And there's your answer. Okay, let's move on to example number 2. John's father is 3 times older than John. In 6 years, the sum of their ages will be 68. How old are they? Okay, let's create our let statement. So let's use the letter x again. So let x represent John's age. Okay, and we're told that John's father is 3 times older than John. So I'm going to let 3x represent the father's age. Okay, so now we have these variables we're going to use, and now we're going to create the equation. I have to be very, very, very careful when creating this equation, because it says in 6 years, the sum of their ages will be 68. So if you're thinking, well, am I going to add x and 3x to make 68? The answer would be no, because x represents John's age today, and 3x represents the father's age today. We want to know, we're only told that in 6 years, their sum will be 68. Today, their sum is not 68, only in 6 years. So what I have to do is just adjust what I'm going to write here. So I'm going to use x plus 6 to represent John's age here, and in 6 years from now, I'm going to add it to the father's age, 3x plus 6 years from now. Okay, so remember, it's important to just note that this 6 represents the fact that we're doing this 6 years later. Okay, so 6 years later, both the combined ages will be 68. So here's the equation that we are going to solve. Okay, and again, I have two binomials here. They're being separated by plus sign, so there's no multiplication, no distributive property to do here. You just simply collect like terms. Okay, so if I remove the brackets, I have x plus 6 plus 3x plus 6, and that's equal to 68. And if I collect like terms, x plus 3x is going to give me 4x, 6 plus 6 is 12, and that's equal to 68. I subtract 12 from both sides. I'm going to have 4x equals 68 minus 12 is 56, and then if I divide both sides by 4, x is going to equal 56 over 4, which is equal to 14. Okay, so now we have an answer for x. X is John's age, and if I know John's age is 14, so John is 14, and then I can find out his father's age. Father is 3 times 14, so father's age is 14 times 3, which is 42. Okay, example number 3. The sum of two consecutive integers is negative 37. Determine the two numbers. So let's start with our let statement. So let x be the first number. Okay, and the next number is going to be, well, consecutive integer. Consecutive means one right after the other. So if x is my number, then the next consecutive integer has to be x plus 1. So let x plus 1 be the second number. Okay, and then when I add them, so x plus 1, I'm going to get an answer of negative 37. Here's my equation. That's the equation I'm going to solve. So let's solve for x. So I collect like terms on the left. If I remove the brackets, I have x plus x, which is 2x. I have a plus 1. That equals negative 37. Subtract 1 from both sides. I have 2x equals negative 38. And if I divide both sides by 2, I get x equals negative 38 over 2, which is equal to negative 19. And you can have a negative answer for this problem. That's completely acceptable. So if my first integer is negative 19, what's the next one going to be? The next consecutive integer above that is negative 18. Okay, so my answer is therefore negative 19 and negative 18 are the two numbers. Example number 4. The sum of two consecutive integers is 54. Find the two numbers. Okay, so again, our let statement. Let x be the first number. Let x plus 2 be the second number. Okay, because this time, even integers. Okay, so I'm going to skip a number. So if I start off with an even integer, the next even integer has to skip count by 2, so x plus 2. And the sum is going to be 54. So when I create my equation, it's going to look like this: x plus 2 equals 54. Solve for x, collect like terms on the left. I have 2x plus 2 equals 54. subtract 2 from both sides, I have 2x equals 52. And if I divide both sides by 2, 52 over 2 is going to give me my answer, which is 26. So x is equal to 26. So if the first number is 26, so therefore 26 and then 2 more is going to be 28. So 26 and 28 are the two numbers. Okay, and again, a reminder, 28 comes from 26 plus 2. Okay, from this let statement. All right, example number 5. Jamie, Lindsay, and Laura went to the local grocery store to buy candies. Jamie bought 3 times as many as Lindsay, and Laura bought 15 candies more than Jamie. If they bought a total of 71 candies, how many candies did each person buy? Okay, a lot of words. Kind of have to break it down step by step. So I'm going to create multiple let statements here. So I'm going to say here, let x, what are my names here? I have Jamie, Lindsay, and Laura. So it makes sense that I may have to make 3 let statements for each of these. So let x be the number of candies Lindsay bought. Okay, and so that's Lindsay. Now, why did I start off with Lindsay? Well, it seems like everyone else was compared to Lindsay. Okay, and then Laura, not everyone, just Jamie was compared to Lindsay, and then Laura was compared to Jamie. So if you follow the chain starts with Lindsay. Okay, so then Jamie bought 3 times as many as Lindsay. So that's going to be let 3x be the number of candies Jamie bought. Okay, and then Laura bought 15 candies more than Jamie. So I'm going to let, if we know Jamie bought 3x candies, then we add 15 more, then we know that's the number of candies that Laura bought. Okay, so those are our 3 expressions for each of the people here. I'm going to combine them to make my equation. So they bought a total of 71 candies. My equation is going to be the number that Lindsay bought, x, plus the number that Jamie bought, 3x, plus the number that Laura bought, 3x plus 15, for a total of 71 candies. Here's the equation I'm going to solve. Collect like terms, x plus 3x will make 7x plus 15. That's equal to 71. Subtract 15 from both sides. I'm left with 7x equal to 56. And if I divide both sides by 7, I will have x equals 56 divided by 7 is 8. So now I know the number of candies that Lindsay bought. So Lindsay bought 8. How many did Jamie buy then? Well, Jamie bought 3 times as much. So Jamie bought 8 times 3 is 24. And then we know Laura bought 15 more than Jamie. So 24 plus 15 is 39. Okay, example 6, my last example here. So the length of a rectangle is 15 meters longer than the width. The perimeter is 74 meters. Determine the length and width. So, okay, so we're told length is in reference to the width. So it starts from the width first. I need the let statement for the width. So let W be the width. Okay, and I don't want to write let L be the length. Okay, I want to have W as my only variable. So I'm going to say length is W plus 15, because 15 meters longer than the width. So it's going to be whatever the width is plus 15 more. So let W plus 15 be the length. And remember, both are in meters. Okay. So my equation, the perimeter, it's a rectangle, right? So let's draw a rectangle. Here's my rectangle. Okay. And my rectangle is going to have a length of W plus 15, W plus 15, W for the width, W for the width. So my perimeter is the addition of all 4 sides. Okay, so if I add up all 4 sides, I will have W plus W plus W plus 15 plus W plus 15, and the total perimeter is 74. Okay. And then when I add them all up, I'm going to have 4 W's here, and 15 plus 15 is 30. That's equal to 74. Subtract 30 from both sides. I'm left with 4W equals 44. And then divide both sides by 4. W will be 11. Okay, so now I have my width. So my width is equal to 11 meters. And that means my length, if I add 15 more, my length is 11 plus 15, which is 26 meters. And there you go. Alternatively, this is my final answer. Alternatively, to begin my expression for perimeter, you could have done, if I have 2 W's here, I could have said here, or 2W plus, and I also have 2W plus 15, W plus 15, so 2 times W plus 15. So I could have started off the perimeter with this expression. So, and then you would have expanded it, and you would still have what I have here already. Okay? But that's your answer, 11 and 26. That ends the lesson.